Okay, so this particular video is for the assessment task that I have been given. So in the task, what I need to build is like there is first part which is smart contract development, and you can see the information here like what do we need to create inside a smart contract, like create a token contract. We should have this particular functionality, and it should also use like ownable OpenZeppelin contracts and should use like this version of Solidity. The second part will be the Node.js backend integration, where we need to use like Express.js for backend server and the Ether.js or Web3.js for connecting deployed smart contracts. And this is like endpoints for minting, burning, and getting. So we need to also create HTTP request in the backend for those functionalities as well. So what I build first of all is token contract, which has the ERC20 contract. Basically, it is inheriting the functionality from the OpenZeppelin contracts, and as well as we are using the ownable smart contract implementation of OpenZeppelin. So who deploys this test token becomes the owner of the contract, and they get minted the 1,000 shares as an initial supply. And there is also a mint function which is only called by the owner for a particular address, and there is a burn function where the message.sender can only burn tokens for themselves. And there is also a balance of function that is been asked for this particular task to be implemented in this token contract, but we don't need to build it because the ERC20 contract from the OpenZeppelin already give us the balance of function, which can be used for like viewing the on-chain data or viewing the on-chain balance of any account. Okay, cool. So this is what I have built first of all. Then after that, I deployed this test contract on the Sepolia testnet using my own private key of dummy account, and but I'm not going to reveal my private key inside the .env file, so will not watch there. So this script basically deploys this token contract, and by the functionality, since we are using our own private key, so this token contract's owner will become our MetaMask wallet address. So this is for the smart contract implementation and the deployment. So let's just check the backend part. So first of all, we have the index.js file which uses express.js, and at the same time we have the token.js which also uses the express.js, and it both has the comes from the same component basically. So we can a user can send the HTTP request by this functionality. For example, if they want to call mint, so what happens is like the logic inside our smart contract or inside our token contract is triggered, and we can see there is two parameter which we have in our token contract because it's going to make us HTTP request to add to our deployed test token contract. So we can see here is like input validations and etc. A similar thing for burn method, like if you want to request for burn method, so same thing happens on chain, and this is for like querying the balance from any address. So let's just see it as practical. So basically we have deployed the token contract. Here you can see the test token, and which is not even published, so we'll ignore it. So I have called the mint and burning logic by making a HTTP request. So let's just see like what happens when we call the mint HTTP request by the express.js that we are leveraging. So let's say we have this command already inside this readme file that I have already put it. So let's just run this command, and since we already know that only owner can call the mint function, so since this was our public key that we used to deploy this test contract, so we'll use only this address. So basically we'll also mint to the owner itself. So let's just run this one. Let's just see what happens. Okay, so I think before that we need to like go into the backend, and then we have to like call the npm run dev in order to start our server. And yes, we can see our server is backend service is running. So now let's run this command. Okay, so it's taking a little bit time. So before it gets completed, we check the blockchain.js file inside the config folder. This is basically the file that uses the ether.js for like connecting our deployed token contract to those API HTTP requests. So we can see that it's importing like a contract address, private key, and Sepolia RPC URL from this env file that I'm unable to share because it also have the private key. So this is error handling, and this is like we are interacting with all those contracts functions like mint and burn through our own wallet, which is this corresponding public key address through the token API. It's essential to use it because through this we can call those functions. So yeah, this is all about this ether.js, like how it is connecting our deployed token contract to the HTTP request. Okay. So now let's just check what happened when we did call the mint HTTP request. So yeah, this token minted successfully, and this is particular transaction hash that we get from on-chain. When this request is delivered to that deployed test contract. So let's just check Etherscan. Let's just refresh that whether our mint call is successfully executed or not. Yeah, we can see like this is the latest mint call that has been executed on this particular contract. So cool. Here we can see that it is signed by this address, which is our own public address, which is the owner of this token contract. You can see here, and it will like mint to the itself because we are minting to ourselves. Here you can see we have minted it to this address, which is the owner address of this test token contract. Cool. So now if we do call burn, so it should print us this message: token burn successfully. So let's just check this one. So lastly, we will call this command in order to see the balance of our accounts or this particular user account. Yeah, it's taking a lot of time. Yeah, we can see here is that the account was the owner itself, and we did minted 50 tokens to it, and it's 18 decimal representation. So it would be better to note it. So yes, this executed successfully, token burn successfully. Cool. So let's just run this command and check how much balance this our owner address own of this particular token, which is this STT token. So it holds like 1190 token balance on chain. So let's just call the burn command, and let's see after that when we run the balance off again through this command, whether we get 20 amount decreased by our by the owner address or not. So burned out successfully. We'll call this command again. Let's see this prior balance is subtracted by 20 or not. Yeah, it's subtracted by 20. Cool. So that is it for this video, and I think I have successfully completed the task that I have been given, both parts, front end and back end.